Hello everyone. Let us now discuss today's LeetCode POTD problem 2116 check if a parenthesis string can be valid. So here we are given with two strings, string s and string locked. So in the input, 1 minute, sorry. In the input we are given with string s and string locked. So here in the string s we can have a string, and in the locked, if it is 1, you cannot change the character, and string s contains either an open parenthesis or a closed parenthesis. Now string locked contains just 0 or 1, and if it is 1, you cannot change it. That means it is locked. And if it is 0, then sorry, in locked, if it is 0, then you can change this parenthesis to this, or to close parenthesis or open parenthesis. Now we are given with an example, and we need to return true if you can make s a valid parenthesis string, otherwise return false. And how can be parenthesis valid? Now it is a valid parenthesis if you have like this, it is also a valid parenthesis, but if you have like this, then it is not a valid parenthesis. Let us take an example so that we can understand. S is equal to 1 minute. S is equal to now here you have the strings s and locked. Now you need to return true if you can make it valid or false otherwise. So the first thing which we need to do is checking the false conditions. So whenever we are asked for returning true or false, then we need to check false conditions. So I think there will be only two conditions whether we return false. So the first thing, initially, if the string size, I think you got the point, if size is 1 minute, size is odd, then return false, because a parenthesis which is odd, like, let me take an example like this one. If it is odd, then without any consideration or any conditions, we can simply return false in these cases. But let us look at this example. S is equal to this, and this string locked. Now here we can change this string, this character, this character, this character, and this character. So the first thing which I want to explain you is, if you have a open brace or open parenthesis and you have a closed parenthesis, this is a valid string parenthesis. Now you have an open parenthesis and you have a closed parenthesis and another closed and another closed. This is the string which we are given. Here you got this open, you got this closed, then these two will be cancelled out. But these two which are closed and which cannot be changed, then they cannot be a valid parenthesis. So let me change this to 0 here and 1 here. This is the locked string and this is the string s. Now 1 and 1, a open brace and a closed brace. Now here, or a parenthesis, now here you got 0. Then instead of considering this as a closed brace, closed parenthesis, I will consider it as an open parenthesis. Now you got this closed. Now it will be a closed parenthesis. Now these two will be cancelled. What I want to tell you is, an open, a closed will be cancelled out. So it will be a condition where open will be, the count of open parentheses will be 0. Now, the thing is, you got this open, you got this closed, but these two which are closed are not, cannot be transformed. Then you cannot close the parentheses which aren't open. So let me write this. You can't close the parentheses which did not even opened. So that means we need to equalize the number of open and closed. So let me take the same example which is given in this description. Now let us take this example. Now here you got this open, sorry, here it is a closed parenthesis, but I will count the open as, if you have a 0 in logged, then I will consider it as a open parenthesis. Now my count of open braces or parenthesis is 1. Now you got this closed parenthesis and it cannot be changed. Then this open, I am not considering the parenthesis, I am considering by using this locked string. That means this can be changed to open. That's why I increased the open count to 1. Now you got this close parenthesis. So here the count of open will be decreased by 1 because this closed parenthesis need one open parenthesis. This will be coming from this parenthesis. That means this will be changed to open parenthesis. Don't consider it of simulation or changing the parenthesis. Just count the number of open and closed parentheses. That's it. Now you got this 0, then you can increase the count, and you got this 1 and you cannot change this closed parenthesis. Then we will be decreasing this to 0. Now you got this open parenthesis, or whenever you got 0, I'll increase the count. Now it is 1. Now you got this close parenthesis. So for this close parenthesis you need this open parenthesis. So decrease the count by 1. So till here you got, so if I change it here, you got the valid parenthesis till now. Now let us check this too. Now you got this parenthesis which is open. So as I said, if it is a 0, increase the count. Now you got this and increase the count to 2. But how can it help me to identify the correct output, or it is to return true or false? Let me check. Let me check how can I do this. So here you got like this. Till here I think we have come to the conclusion, or here it is till here. Now it is satisfied. So the number of open are equal to the number of closed. So let me change one thing. Let me change one thing. Here, let me take 1. Here, let me take 1. So if I got a closed parenthesis, then I need open parenthesis. But as I decrease the count, whenever I got a closed parenthesis, I will do the same. I will decrease the count and it will become minus 1. As I said, you can't close the parenthesis which did not even open. That means the number of open parentheses are 0, but you need another parenthesis, a open parenthesis for this closed parenthesis, right? So in this case, our count of open parenthesis is going to negative. So here itself you will return false. So that's how you solve this problem. But wait, what about this closed parenthesis? Let me go through that too. 1 second. So closed parenthesis. So here it will be 0 again. But should I count from the starting? No, no, right? In open, you will have the count from the beginning. So if there is open, then you need to count for the you need to find the closed parenthesis after this open. That means you will go forward. If you get this open, then you need to count for the closed. If you get open here, then you need to count for the closed in the next index. So when I want to search for a closed parenthesis, you got this closed parenthesis here. So the closed parenthesis itself start from the end. Then to get that, you need to move to the previous index. So I will return. So I will iterate in the reverse. Now, what I'm gonna do is, you got this closed parenthesis. So let me increase the count by 1. Now here you have this 0. 0, that means you got a closed parenthesis. That's it. Don't ever look at whether it is this a closed or open. If you got 0, then increase the count. Now you got this again a 0. Now increase the count. Now we are at this index, so it is closed. Now we are counting the number of closed parentheses and it is 1. So it is logged. Then increase our count of closed to 3. Now you got this. But I can change it to the number of closed, so it can be changed to closed or open. So I'll increase the count. So now you got this closed and increase the count to 5, and you got this uh, 0, then increase the count to 6. But does it make a sense? Because we have all this as closed parenthesis. Closed parenthesis. You have counted everything. Here the size is 6 and the closed parenthesis also is 6. But wait, let me come here. Here you got 3 parentheses, but which are already closed. Now, what if you got, wait a second, let me change this example to something like here. Here you got, it is like a open, and here it cannot be changed, and here it is an open, here it is open, sorry, here it is open, and yeah, these all are locked. So wait a second, so these are all locked indices till here. Now you got these 2 closed parentheses till here, you got these 2 closed parentheses till here. Now as I said, till here you got 2 closed parentheses. Now let me count the number of open parentheses. So here you got an open parenthesis. So the count of 2, 1 minute, the count of 2 will become, the count of 2 will become 1, because this closed parenthesis and this open parenthesis will cancel out each other. So wait a second, you got again 1. So that's the count of closed. So here you got to this index and it is open. Now decrease the count to 0. Yes, decrease it to 0, because this will be equalized. But wait, here you got another open parenthesis and another open parenthesis here. So that's why I am decreasing the count to 1. Then I'll go to the negative count. So that's why this is the way. Whenever you got a negative count, then there itself return false. So see here, you cannot change this, right? Even if you change this open parenthesis to, sorry, closed parenthesis to open, then you cannot get a valid parenthesis. So this is how you solve this problem. I think you got the all the intuition to solve this problem. So if you came from LeetCode from the discussion box and only you need the hint or the intuition, then leave the video here itself and try for the algorithm and code. But if you need algorithm, stick on to this video. So you got the algorithm. So initially, if size, as I said, if size is odd, then return false. If size is odd, return false. Then the count of open will be 0. Then iterate from beginning. If s of I is equal to an open brace or open parenthesis or log of I is equal to 0. So do I need to check whether s of I is open? No need, right? So if I got this log of I is 0, then simply I can change it. But it will go to a condition only when there is open, then only it will consider this as open parenthesis. So it is important, if log of I is 0 or s of I is open bracket, then only increase the count of open. Else, that means the bracket is closed, then decrease our open count. But by doing this, if open gets to negative, then return false. Sorry. Then here the count of closed will be 0 initially. So sorry for the disturbance. So closed is 0 initially. Iterate from the end, and if s of I is equal to a closed parenthesis or log of I is equal to 0, that means we can change it to a closed parenthesis, then closed will be incremented, and else if it is an open parenthesis and it cannot be changed, then decrease the count of closed, and if the size of the count of closed is less than 0, then return false there itself, and if these two conditions are not satisfied, then return true, and you will get the code. And even if you want to try the code by using the algorithm, you can try here itself. Now here, 1 minute, int n is equal to s dot size. Now if n percentile 2 is equal to 1, then return false, then it is odd. Wait a second. Now open is equal to 0, int open is equal to 0, and iterate from the beginning. For int I is equal to 0, I is less than n I plus plus. If s of I is equal to open parenthesis or log of I is equal to 0, then you can change it, right? Open will be increased, and else decrement the count of open. Now if open becomes negative, then return false here itself. Now for int I is equal to n minus 1, I is greater than or equal to 0, I minus minus, iterate from the end. Int closed is equal to 0, and if s of I is equal to a closed parenthesis or logged of I is equal to 0, that means it is unlocked and we can change it to a closed parenthesis. Then increase the count of closed, and else decrement the count of closed. If closed is less than 0, then return false here itself. Then return true if these conditions are not satisfied. So if you like my explanation, please like this video and share to your friends and subscribe to my channel. Thank you.